Ever pondered how biological evolution harmonizes with the laws of physics? Enter assembly theory, a revolutionary scientific framework that offers an answer to this enigma. This innovative theory redefines the concept of an object, introducing a new measure known as assembly. This measure quantifies the degree of causation necessary to create a given ensemble of objects. Assembly theory ingeniously incorporates elements of novelty generation and selection into the realm of physics, specifically for complex objects. It's not merely a theory, but a robust interface, a bridge, if you will, that connects the seemingly disparate worlds of physics and biology. This framework is not only groundbreaking, but also provides a new perspective on how we perceive the world around us. It offers a novel way of understanding how complex objects come into existence, following the laws of nature, yet influenced by the principles of biological evolution. In essence, assembly theory provides a unified language, bridging the gap between physics and biology. So, what is an object in the world of assembly theory? Well, it's not as straightforward as you might think. In the realm of assembly theory, an object is a concept that's been redefined. It's no longer just a thing that you can touch or see. No, it's more than that. An object, in this context, is something that is finite, distinguishable, and persists over time. But there's a catch. It's also something that can be broken down into elementary building blocks. Let's think about it for a second. Picture a Lego castle. It's finite, right? It's distinguishable from other objects and it persists over time, but it's also made up of many smaller blocks, the fundamental building units, if you will. Each block in turn contributes to the castle's final form. This is a rudimentary but apt analogy for how assembly theory views objects, but there's more. In assembly theory, we also talk about the assembly space of an object. This is essentially the pathway by which an object can be built from its elementary building blocks. Back to our Lego castle, the assembly space would be the different steps you take to construct the castle, the order in which you place each block, and how they all fit together. This approach is not just a novel way of looking at objects. It's a powerful interface between physics and biology, a unified language that allows us to describe the generation of novelty and the process of selection. It's a bridge between two fields that on the surface may seem worlds apart. Assembly theory doesn't just redefine objects, it redefines our understanding of the world around us, providing us with a new lens through which to view the complexities of everything from biological evolution to the laws of physics. It's fascinating, isn't it? How assembly theory redefines the very concept of an object. But what about predicting future discoveries, you might ask? Well, that's where the beauty of assembly theory truly shines. This revolutionary framework allows us to predict the features of new discoveries during the process of selection. It's like having a glimpse into the future of scientific breakthroughs. Imagine, if you will, a vast assembly space filled with objects. Each object, defined by assembly theory, is a unique combination of elementary building blocks, distinct in its makeup and the pathway by which it was constructed. Now, as selection occurs within this space, assembly theory quantifies the degree of causation, or the amount of selection it takes to produce these observed objects. In other words, the theory provides us with a numerical value, a measure of the complexity and novelty of an object. This measure, referred to as assembly, can then be used to forecast the features of potential future discoveries. It's a bit like predicting the weather, but instead of clouds and precipitation, we're predicting the properties and features of yet undiscovered phenomena. The possibilities are as endless as they are exciting. With assembly theory, we can even forecast features of future discoveries. So you see, assembly theory is a game changer. It's more than just a new scientific framework, it's a whole new way of looking at our universe, reconciling the intricate processes of biological evolution with fundamental laws of physics. It's given us a fresh perspective on what we call an object, defining it as something finite, distinguishable, persistent, and ultimately composed of elementary building blocks. But perhaps the most thrilling aspect of assembly theory is its predictive power. With this theory, we can anticipate features of yet-to-be-discovered phenomena, quantifying the degree of selection necessary to bring about observed objects. It's like having a roadmap to the unknown, a compass leading us to scientific breakthroughs we've only dreamed of. And let's not forget the most significant achievement of assembly theory. It's built a bridge, a powerful interface between physics and biology. It's a unified language, a shared lexicon for two disciplines that until now seemed worlds apart. So you see, assembly theory is not just a game changer, it's a universe changer. If you want to stay on this journey of discovery, to continuously be enlightened, like and subscribe